all the way to the end of the notes. This is probably the most complicated question in the entire chapter 3. And so this is why I want to do one of these as an example for you. I'm going to be finding all of the zeros. This is the how-to list that I would have gone over with you in class. So please follow this closely, and I'm going to be working on number 64. Now, the first thing I notice about number 64 is it has fractions, and I know that you don't love fractions. So I say, let's go ahead and get rid of those fractions. And my common denominator here is 7, so let's just take both sides of the equal sign and multiply by 7. When I multiply by 7, the left is just going to be 7 times p of x. I'm not too worried about that. When I take my 7 and distribute it to all the terms on the right-hand side, my first term is just simply going to be 10x to the 4th. My next term is going to be negative 7x cubed. Negative 49x squared is the next one. Positive 35x. And a minus 5 for the last term. So now I'm ready to start incorporating some of the things that I know to do according to my how-to list. First of all, how many zeros am I looking for? Well, the degree is 4, so we're looking for 4 zeros. And we know that to get some good guesses, we need the factors of the leading coefficient. It's going to be 1, 2, 5, and 10. And we also need the factors of the constant, which is just simply going to be 1 and 5. So you remember from our how-to list and from class that in order to find these good guesses, then I need to take the factors of the constant and divide the factors of the leading coefficient. This is not a good way to write it, but it does get us in a good start. So we have to divvy up everything. So the first thing I'm going to do is I'm going to take my 1 and pass it down to the 1, and then 1 over 2, and then 1 over 5, and then 1 over 10. So this is the method that I'm going to choose. So my first one is a plus or minus 1 over 1. My next one, plus or minus 1 over 2. My next one, plus or minus 1 over 5. And my last one, plus or minus 1 over 10. And I'm not sure where that one went, but I might find it here in just a moment. For my next round, we've got plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 5 over 5 I've already done, and there's my plus or minus 1 over 10 that I was missing there for a moment. All right, so now that I have my good guesses, I'm ready to plug this into the calculator. And so what I've done is I've actually given you a graph here that I graphed on my iPad. And the blue graph is the graph of the one with the fractions. The red graph is the one without the fractions. The main thing I wanted to show you is that there are 4 zeros, and all 4 zeros occur at the same place, regardless of whether I'm using the fraction version or the pretty version. So it doesn't really matter which one you plug into your calculator. I see that I have a 0 on the outside of the negative 2 and on the outside of the positive 2. I'm not going to worry about those. Let's look at the 2 zeros between 0 and 1, right there in the middle of your screen. And so when I go back to my good guess list, the only possibilities that I have here that are between 0 and 1 are either going to be the 1/2, the 1/5, or the 1/10, all on the positive side. 1/2 is probably the easiest number to plug in, so I'm going to stick with positive 1/2 and we'll see if it's a good zero. So I make my list of coefficients. Yes, definitely use the pretty ones. You don't have to use the fractional ones. And inside the box, we're going to put 1/2. And then we're going to do our synthetic substitution to see if it's a 0. And I'm not going to walk you through the synthetic substitution. You've learned this in class. So what we find, though, is that, yes, it does give us a 0. So then the other one is going to either be that 1/5 or the 1/10. 1/5 is probably a little easier to plug in. So let's try that one. Remember that you don't want to go back to the beginning. Make sure that you're using the depressed polynomial to plug in your number. Do not go back to the beginning. So using this then, synthetic substitution again, I find that 1/5 also provides a 0 for me. Not only that, not only does it provide a 0, I now have a quadratic down here, and we know how to solve quadratics. We've got 4 methods for solving quadratics. So that's what I'm going to do next. I'm going to take 10x squared minus 50, set it equal to 0, and let's solve. We'll use the square root property for this. Move 50 over, divide by 10 so that I have 5, and then take the plus or minus square root of both sides. So now I have all of my zeros. So go ahead and list those out. We've got x equals 1/2 and 1/5. Those are the two I found on the graph. And then positive root 5 and negative root 5. Take your 4 zeros, turn them into factors. Again, we know how to do this just by moving over to the left to be with the x. And then I can take my factors and I can write my polynomial. Now, before we get anywhere, let's take a look at what the directions were. List the zeros, we did that. List the possible zeros. Graph, we did that. We found all of our zeros, but now what we're trying to do is we're trying to factor our p of x. So let's go ahead then and write down our factors, all multiplied together. And the one thing that many students forget is they need to check to see whether the leading coefficient of their factored version matches the leading coefficient of the original version. Now, our original version had a leading coefficient of 10/7. They don't match. So the very last thing then that you need to do is just to make sure, slap the leading coefficient back into your p of x.